flavors. And then they have a Nexus 4000 and a Nexus 2000 and a Nexus 1000, right? And they all play their own little role in the marketplace in the data center segment. The 7000 is like a giant, basically data center core switch, right? With the current generation of fabric modules, which are like the backplane modules that provide the backplane of the core switch itself. You can put 5 of those in the chassis, and each one of them gives you 46 gigs of bandwidth per slot in the chassis. So if you load a chassis up, a 7000 chassis up with 5 fabric blades, you can get 230 gigs of throughput per slot.
What's one of those go for?
I'm not a sales guy. I don't work on pricing, but it's not cheap.
Probably more than I'll make in the next 10 years, easily.
Right. Well, I can tell you that I've been speccing something out for one of my customers, and I'm looking at putting I'm buying 4 of these 7K chassis just for this one project, and each one of them is going to have 5 32-port 10 gig Ethernet blades in it. And each one of those 32-port 10 gig blades is retails for about $70,000.
Ooh.
So it gets a little pricey, right? I got to keep myself employed. So, but nobody ever pays retail price for Cisco gear, so it doesn't matter, right? Most people get a pretty empty discount off it. I mean, I don't know anybody that pays list price. You got to be in the sales figure more. But so we have all this cool stuff happening, like all those Nexus products. Well, I guess I'll continue going down the list. The 5000, which is right below the 7000. The 5000 is meant to be a high-speed, layer 2 wire rate switch, right? So like the 5020, for example, you can get 40 ports at 10 gig Ethernet, and you can actually transmit 10 gigs on each port at wire rate. So you can have all 40 ports connected at 10 gig Ethernet, sending 10 gigs worth of traffic at the same time, and the switch won't choke. So,
Wow.
There's that. And it's meant for, data center kind of high-speed access layer, either 10 gig to the server or, maybe switch interconnections or high-performance compute. Or, there's several other uses for it too, but that's basically what that is. And there's also a variation of the 5000, 5500 that does now layer 3 that's coming out shortly. But, you get down below the 5K, and you have the 2K, which is actually a pretty cool product, right? I mean, people look at data center architecture and they say, well, wait a minute, I don't want to have all my servers in my racks and then have to run cables back from each one of my servers back up to my core or back to a centralized location. That's a lot of cable if you're looking at an enterprise with each server that has several network connections, right, depending on what it does. So what a lot of people are doing with the 2000 is that's meant to be like they call it basically a remote line card, right? So in addition to saving you the cabling costs by being able to put the network edge closer to your servers, you also get the remote line card functionality, which is basically when you connect it up to its parent switch, whether it be a 5000 or 7000, it looks like an expansion off of that parent switch, so you don't have to manage it separately. You don't log into it as a separate switch. So it's kind of a handy feature. And there's several things that all these products bring to the table. There's a Nexus 4000 that goes into the back of like a IBM blade center. So now instead of having several cables coming out of the back of your blade center for every blade or whatever, you have it aggregated inside of the fabric of the chassis of the IBM blade center and have the aggregate connections come out of this Nexus switch that's built into the IBM blade center. So that's basically the 4000. And the 1000V is actually a pretty cool product too. It's a software-based switch only, and those of you that are familiar with VMware might know a little bit about the V switch that's inside of VMware, right? Mm-hmm. Well, that switch, I mean, basically what it does is it's a software product that says, you make a .1Q trunk to your host server, and then you can take that physical link to your host server and kind of put your virtual machines on different networks or on different VLANs, and that's all configured inside your little vSwitch. But where that leaves off is, from a network person's perspective, people like me like to be able to log into the switch and troubleshoot things. So if you're having a problem with a VM and your access layer is technically that virtualized vSwitch, the network people like me have no visibility into that, right? And the functionality of that is limited. So with the Nexus 1000V, it's actually a replacement for the VMware vSwitch. And you install it on your VMware server and it runs as a distributed vSwitch inside of VMware. And you can log into it just like you would a regular Cisco switch that runs the NXOS, the Nexus software.
Nice.
And it's familiar to, to people that know data center because, hey, to me it just looks like another switch. So I can actually have visibility down into my virtualized access layer and say, hey, this individual VM is sending this traffic and I want to apply this QoS or this security policy, or I want to be able to troubleshoot it and run a span session so I can see what traffic is coming in and out of that VM so I can look at a packet capture and figure out what's going on with my application. All that sort of thing you can't really do with the built-in VMware vSwitch. So that's kind of a partnership that Cisco has going on with EMC and VMware to make that happen. In addition, you can do other cool things, like if you move VMs, if you vMotion VMs across physical hosts to different servers for redundancy purposes, or say you want to do maintenance on a physical host and you don't want to schedule a maintenance window and you move your virtual machine over to another host so you can work on its original server. Well, you can actually have the Nexus 1000V, the configuration for that machine to follow the virtual machine. So if it gets dynamically moved to another box, you can say, well, every policy that I had applied to this virtual machine, whether it be security, QoS, VLAN configuration, whatever, it's going to move with that virtual machine over to the other physical host. So you don't have to worry about managing that access layer anymore. So it brings a lot of benefits there. So that's basically the Nexus product line. And that whole product line is, I kind of glossed over it at a high level, but the entire product line is kind of Cisco's big move into the data center marketplace. And there's a lot of innovations like the port profiles, which is the configuration moving with the VM, and the ability to aggregate connections out of a blade server, and all this other stuff that this operating system brings with it that kind of gives us a little bit of an edge in the marketplace. NXOS, for example, which is the new operating system that runs on all this Nexus gear. I know some of you were at Ohio Linux Fest. I was just there a couple weeks ago. You log into it, you see a GPL. It runs Linux. The switch is a Linux box. So, those of you that are familiar with Linux, you can log into the switch and you can run commands and grep stuff and see the output of the stuff that you run in the switch. So, a lot of people that run Linux are really geeked about the new operating system because you can do things with the switch that you wouldn't normally be able to do. You see a lot of people that are familiar with Linux and Unix log into network devices now and they're like, hey, I can grep stuff, I can awk stuff, I can do all this other cool stuff. So that's kind of cool. And with that, you get all the resiliency benefits of a Linux or a Unix box. So you have process level high availability. So everybody likes Linux, right? Because if you have a problem, you don't need to reboot your box, right? You can kill a process and restart a process. And same thing is true in NXOS, right? If you have a problem with one piece of your switch, first of all, it doesn't just load every piece of code into memory, and just hope that you use it, just like, the previous operating systems did, right? You enable different features, and as you enable features on the switch, the operating system loads those features into memory, and then now they're available for use. And then if you have a problem with a process at some point down the line, or your network becomes unstable for whatever reason, and something stops working, instead of having to reload, your switch or have it cause some sort of problem, we're pushing for high availability, right? So we can, kind of transparently restart individual processes in the background and kind of keep your network running while that sort of thing happens, because nobody's perfect. And this is just kind of our ability to drive that high availability that kind of makes the operating system unique. With the 7000, which is the big core switch, you can do a lot of other cool stuff in the Nexus operating system. We have a technology called VDC, Virtual Device Context, where you can now carve a Nexus 7000 core switch up into 4 virtual switches. And you can actually run them independently and manage them independently. So you can create a VDC and then assign your network ports that are physically on your switch inside of a VDC. So you can say, this port belongs to this VDC, or that port belongs to that VDC, and they're managed separately. The OS is virtualized inside of the switch, so they're isolated from a fault perspective. So you can have problems with one VDC not affect the other VDC on the same switch. So you can do some really cool stuff with that. And it's all managed independently. So you can say,